Okay, so picking up exactly where I left off in the previous video, what we did was we set up the lights. We set up a few animation parameters to get this to kind of animate and simulate when we wanted to. And we also set up some lights to complement our scene. And we also learned how to go ahead and associate these lights with particles. And we also saw that particles, when using the volume shaders, can't be associated using the traditional method with lights and XSI and 3D objects. We had to use a little workaround using the light restrictions list inside the shader. Okay, so now what we're going to do in this video is just go over our work here, make sure everything's working the way it's supposed to. If anything's not, we're going to go ahead and tweak it and fix it. Let's go back to the first frame of the animation. Let's do a render here of the flamethrower. So everything looks pretty good right there. If we play forward a little bit, we can see our torch effect right here is working. Okay, very good. Now if we go ahead and play forward even more, sooner or later somebody squeezes off the trigger here and these flames just start to rip it up. Okay, and if let's just go far back here so we can see the whole thing and render this out. It's rendering out relatively quick. There's our flame effect. I would hate to be on the business end of this flamethrower. Would not be a good position to find yourself in. So we have this nice flame effect coming out here, burning whatever's in its way. All compliments of ice. Okay, perfect. So everything's looking pretty good. Let's recap here some of what we've done. Okay, we have the flamethrower, we have some emitters. If we go to the Explorer here, we have a flame emitter and an ignition emitter. The flame emitter is controlling these big old flames from the flamethrower. The ignition emitter is controlling the emission from the little torch that starts the flames. Okay, those things are emitting the particles. If we select these particle clouds, for example the torch, and we come here to the ice tree, we can see that it's a pretty simple ice tree setup. Here's our main ice tree execution node, and then we have our different nodes here, like our emit from surface. We have an age limit set up for it, pretty uniform age limit. As you can see, it ends at 0.75. There's no randomization there. We're also modifying the particle size so that if I come in over here, play this a little bit, you see that the torch here starts off pretty big and then gets smaller as it gets to the end of its lifespan. And that's what this modified particle size is doing. It starts off big and then just drops down with this curve until it becomes really small. Okay, and it's using the age percentage to determine the how that F curve modulates across the lifespan of the particles. Then we're killing the particles once they reach their age limit, which is being determined here by this node. And then of course this node down here is making the whole thing work by simulating the particles at the frames when they're supposed to. Okay, so that's how that's working. Then we have this little blue light right here, which is creating this sort of cyan bright blue light that's affecting our scene right here. And the light is actually affecting the geometry in our scene, which in this case is the tip of the flamethrower. It's also affecting the particles here. So without this light, the particles would be darker and wouldn't have this nice little lit up flamey effect. Okay, all right, then if we play this a little bit further, we have these flame particles which are being animated. They're set up so that their emission, if we go over here to the ice tree, the emission has some animation on it, which is why you have this little icon here which represents that there's animation here. And if we right click and open up the animation editor, we can actually see that there is in fact animation here. Here's the first frame of the animation, frame 100. Then when it gets to frame 130, the emission reaches a rate of 1000. So 1000 particles per second. Okay, then we have our age limit here. So our age limit is being set up by this turbulized value by range, which is being controlled by two more turbulized value by range parameters, one controlling the minimum and one controlling the maximum value, which adds a little bit more randomization and realism to the fire effect. Then down here, we're also modifying the particle size using this F curve. So the particles start off pretty small and then get bigger. And then there's this sort of little notch here to add a little bit of randomization and not let it look so uniform. And of course, we're using the age percentage again to make the particles change size based on how old they are in the simulation. And we can see that pretty evidently here. Here's the beginning of the F curve where the particles are small, and then they have a little notch somewhere around here, and then they get real big down here. Create a nice big flaming effect that's very difficult for enemies to run away from. And then we have this turbulized value by range node or compound, which is actually adding a little bit of randomization to the multiplier parameter of the modified particle size compound. Then we're spinning the particles here. After this happens, the particles are spun, and if we open up its PPG, they're spinning in a spiral, and they're spinning in the x-axis a little bit, and they're also spinning in the y and the z-axis. And the spin rate's pretty low at 0.5. We can actually increase that spin rate if we wanted to, make them spin faster or slower. 0.5 works out pretty fine in this case. And then of course we have all of our little forces tree branch over here. We have an add forces, which is taking all of these forces like the null controller force, gravity force, and the turbulized round value compound, and it's piping it all into our ice tree over here. Okay, the null controller force is using a null in our scene, which is this null right here, to go ahead and push these repel sort of these particles in the y direction, which has been defined down here using this use input force direction parameter. And it's a pretty strong force, a force with a strength of about 20. Okay, so let's close that. Then we have a gravity force, which is exerting a little bit of force on here, 0.5, positive y direction, so it's pushing them up, which is pretty much how fire tends to behave in real life. Fire likes to go up. You never see fire burn down, really. At least I've never seen it do that. And then we have this turbulized round value node, which shows us that we're not limited to using only these force compounds with the add forces compound. We can actually use a turbulized round value node or compound and plug it into the add forces compound over here. And what we're doing here is adding some variance with the turbulized node. We're adding some variance to the x, y, and we're not adding any to the z parameter, just the x and y. So it snakes left and right and up and down. Then we have some turbulence scale, and we have our animation speed set up and our animated parameter checked on. And that's all being plugged into this add forces node, which combines all those forces and effects and pipes them right into the ice tree. And then down here, of course, we have this node here, delete particle at age limit, which kills off the particles once they reach their age limit, which is determined by this branch over here of the ice tree. And then, of course, finally, our simulate particles node, which makes the whole simulation come together and work. Okay, so let's close that. So that's pretty much a recap of what's going on right there. Okay, remember that the flame controller here, this null, actually affects the particles based on its position as well as its size. So if it's really big, it's going to have a lot of effect on these particles. If it's really small, too small, you won't really see an effect on the particles. Okay, so that's pretty much how that works. Now, in terms of shaders, the shader setups that we have appear to be complex at first glance if we open up the render tree for the flames, but it's pretty easy to understand really once you get the hang of it. You have the material node here. The particle renderer creates the actual volumic effect and goes plugged into the volume input here of the material node. There's nowhere else for you to plug it in because volume shaders can only be plugged into the volume port of a material node. So that pretty much makes it very easy to plug it into the correct place since you only have one place to plug it into. Particle renderer determines different things like the quality and things of the renderer. And let's go ahead and increase this. Let's put this at high settings. And let's change the cell size to 0.75 so it renders out nice and crisp. And over here we have some volume color and particle color nodes, but we're controlling the colors with a gradient, so we don't worry about that. Density is set up pretty high to 400 here and the density limit to 10. And over here we have the particle shaper, which is controlling the shape of the particle cloud. And then of course we have the particle gradient, which you saw we're using to give it the nice fire look by controlling the colors here of the fire. Okay. And then we have the gradient position, which adjusts the position of these colors on the actual particle. And you saw how we can actually input these fractal scalar nodes and cell scalar nodes into these different inputs. And we have 6 different inputs that we can use here. So we have 1, 2, 3, 4, 5, and 6. In this case, we're using 3 and 4, and we're not using 5 or 6. And then we have, of course, the particle gradient F curve, which we have plugged into the gradient density here, which is controlling the overall density of the particle cloud. So we can control this, make it look less dense or more dense based on the look that we're going for. Okay. And if we go to the torch here, have a quick look at its particle, its shader tree. It's not very big. We're using a particle gradient, 2 of them to control the color and the density. And here we're using the more complex shader setup where we're using the particle volume shader instead of using the particle renderer compound, which normally makes it easier and faster to work here. And what we're doing here is using this node here to control all this stuff. So we have this set to highest settings. If we go to the lookup table, we have the cell size set to 0.1, which is a very small number, but it's necessary in order to get this small torch effect to render out correctly. And if we go to shading, we're restricting the lights that can affect this particle cloud only to the ignition light, which works great because it lets us control which light affects the particle cloud, in this case the ignition light particle cloud, and it also renders faster because only one light is affecting this cloud, as opposed to us not using that feature. All of these lights in the scene would be affecting that particle cloud, which slows down rendering by a lot. Okay, so that's our setup. That's a recap of everything that's going on here. Let me go back to the flame particle cloud shader. Let me make sure that I have the settings turned up. Okay, I have high settings and my cell size is set to 0.75. So again, the quality will be controlled by that cell size and by the setting of your particle cloud. Set it to low, default, or high, and also the anti-aliasing settings of your of mental ray. So there you go. There you have it. There's our nice flamethrower. We can see it snaking along very nicely. And we can come in here and make a render preview real quick. You can do that coming over here to render and go to render preview. Actually, it's over here. Go down to this preview button, and if you hit that, you can do a render preview. Mine's is set to 400 by 270. Just so it renders faster, and my settings are up pretty high. And I'm not going to go ahead and render. It's just going to take too long to render this out at the highest settings. So I'll leave that to you. When you have some spare time, go ahead and render it out, and feel free to go into the shader and tweak it. You can tweak this to your heart's content. You can add more inputs to this. You can do all kinds of crazy things to it to change the look of it. Maybe if you want to do a blue fire or more of an oily fire, as opposed to my fire doesn't look very oily. But you can do whatever you want. You can even make this gun shoot out smoke instead of fire. So the possibilities are limited only by your imagination. So go in there and start using ice for production and start using it to do all kinds of cool effects like you saw here with FlameThrower. So thanks for watching. Thanks for supporting i3D. I hope you really enjoyed this tutorial as much as I enjoyed creating it for you. And have fun with ice. Feel free to drop by our forums and let us know what you think, and show us some of the ice effects you're working on in your free time or even in your production if you're allowed to do that. So take care. Until next time, this is i3D Jack. Thanks from all of us here at i3 Tutorials. Thanks for your support.